1, 2, 3, 4, 5. Okay, let's hope it's better now. Somebody said that the glitching happened also yesterday because I opened a terminal. So let's see if it's better now. Sorry. So right now I hope glitches will disappear, but they don't seem to. Minimize OBS. Let's try that. Okay, so the theory was that I have to minimize OBS. Let's try that again. Now maybe you will see glitches, just to test the theory. And of course there is some delay, so I don't see it immediately. Yeah, so it's OBS, it has to be minimized. Cool software. Okay, let's move to a problem. So it's important to know the simplest algorithm to check if a string is a subsequence of the other string. And now the general approach to questions with counting distinct subsequence is that when you are given a string, and just let's say we want to count different subsequences of that, then we must do some dynamic programming, and it will be, let's say that the first letter should be A of that subsequence. And so then what we should do is we should move to the first A, just not to any, to the first, and then let's say the next letter we want it to be C, then let's move to the closest C to the right. And if we are given like a stream of letters, just to know the order, then we will not count anything twice, because for every subsequence, possible subsequence, for every string that is a subsequence, we'll only count it once. We will only count it for the very first occurrence. So actually, instead of solving this problem, let's first solve something simpler.
1, 2, 3,
so
4, 5.
for a given string, let's count distinct strings that are subsequences. So we are still glitchy. Maybe. Okay.
Okay.
Let's
I hope you can hear me.
create a new
On my
program.
laptop, I hear myself. Yeah, awesome. Okay, hello everybody. So
And later
I think it's still
I can fix the glitchiness, unfortunately. Let's make sure that OBS is minimized.
I think the arena is frozen. I didn't
I can
do very
also
well
try
because
to
I
close
couldn't
this
solve the
terminal.
medium problem.
But
I didn't know how to use grandy numbers.
I just don't understand the issue.
And I'm not sure about my hard problem. So we'll see.
Let's read a string.
Okay, I would right now open.
Let's say that it consists
anything,
of letter from A to Z.
But the arena doesn't let
And
me.
now what we should do is create some dynamic
right
program.
now you can only see what
for
I
a
tried
moment,
to
let's say that it's of
do
size
and
26. It will actually be something different.
On my computer.
I
I tried to solve it for one
Let's
dimension,
create.
and I
make it
printed all the
two-dimensional.
tests for which the distance. Sorry,
If you're not familiar with
false,
vectors,
so all
it's
the tests
equivalent
for which
to
the first player
an
loses.
array of size n
And
times
there is some
26.
pattern in those
And
with
for every
distances.
place,
I tried to Google that,
and
but
actually I think we will not
wasn't,
need that extra
I
dimension.
couldn't solve
For
it.
every place,
So
which
I guess I
we would
overthought.
want to know the number of distinct strings
Okay,
that
I
are
think now
subsequences up to this point. So actually I will change that to this.
So somebody said we have
anyway.
Google Kickstart in 20
And
minutes.
the goal is not to double count anything.
But fortunately, you will be able to watch me later
if
in video on YouTube. So
we iterate over a position, so we know
the statement
we had some subsequence to the left,
perimeter,
and now we start from this position.
Any triangle
we can iterate over a letter
coordinates.
So let's say that the next letter will be called
coordinates.
Next letter.
Coordinates could be only up to 3000, actually
Z.
up to 1000, because well.
Now let's find the first occurrence of that letter.
And you could use the fact that there are not so many.
We move to the right until we get
segments.
next letter.
So, for
the
if there is some pair of
J
points,
is different than next letter.
the
letter
distance between them
plus J
must be integer in this.
And
this
now,
problem.
if we indeed found that
prove,
letter, we can assert that.
What we have to prove is that
exactly this letter.
If the distance isn't integer,
what we should do,
then
we should
increase
dynamic programming of some place.
So it will be of form
the number of ways
of some number, and
so what we actually
lemma would be to prove that
we start from dp of 0.
Roots
I will need
be integer
plus 1 here.
Those
we start from dp of 0, and we know that we have one empty string. And if we want to extend that string, we must start from position 0. If we want, for example, to make C
so all
the first letter,
segments,
we must find the first C.
Pairs
so the meaning of this
distances A and B,
dp of I denotes
x and y coordinate,
the number
such that the sum of those pairs will be
the number of strings
a square
that are
an integer number. So basically we try to find Pythagorean triples. And
ending at I minus 1 means that if you do that greedy algorithm to find the first occurrence of our next letter, then you will finish the string exactly there.
1000 square.
And the logic behind that is that if you already fixed some beginning of that string that is a subsequence, it doesn't matter what it exactly is.
And then
what matters is how much to the right you already moved.
So then we have
and thanks to this, you know what to the right you can use.
The third remaining segment is also
the idea
integer length, and whether the area is as required. And to compute the area, it's easier.
Do we still have glitches?
To use the cross product. So you can see cross product here in
close the video in background. Okay, I can do that. Okay, thank you everybody. Maybe there should be a list of things that should be closed, not to have glitches. And let's test this solution. So answer will be just the sum of values in dp. And let's test it on some input. I'm in wrong directory, and let's also see if I caused glitches with this terminal. Can you repeat what you said? So which part wasn't during which part I wasn't heard? Okay, so I will repeat everything about the coding. That's a bit sad, but okay. We use the greedy algorithm. So for every, let's say that someone told us that string, and we want to check if it's a subsequence of our long string. Then we do the greedy algorithm. Here, if we want to count distinct strings, what we do is we define dp as I wrote here. So dp of I is the number of strings, distinct strings, that are subsequence up to this moment. Because if you have some distinct strings, for example, maybe the input string is A, B, C, D, E, then strings AC and strings BC and also string C could be extended in the same way to the right. Also, if there is something like, if there is more letters to the right. Why is that? Because if we do move greedily from the left and we stop at C, then the fact that we took A or B doesn't affect us when we take something to the right. For example, after that C we can take D, E, A, or maybe something else, but we can do it in all these scenarios. It's also the same for ABC. So instead of separately iterating over those possible substrings, what we should do is to remember that there are 4 strings ending with this C. So actually we would say that dp of, I think, 2 or maybe 3, it will be 3. dp of 3 should be 4 in this example because there are 4 strings ending with C. Okay. And now we just implemented that, so we moved over position, and the next loop iterates over the next letter. Below we find that next occurrence, and if we indeed found some occurrence, so if j is smaller than n, so we found something to the right, we assert that it's indeed this letter, and we increase the number of ways, so the number of strings ending at some position. Now we will test it on some input. So for example, for the string with 5 letters A, okay, I shouldn't use this terminal at all, I think. I will use terminal below. With 5 letters A, I expect answer 6 because there are 5 strings consisting of A and 1 empty string, and indeed it's 6. If the input is ABC, I hope to see 8 because every possible subsequence is a different string, and I get 8. Something a bit more complicated, maybe ABB. So then I would expect to get empty string, only A, only B, BB, AB, and ABB. So 6, I hope. And yeah, it's 6. It's a bit better to first, when you create a test, to first find out what the answer should be, because if you first run your program, then you'll find 6, and you start like counting the substrings, like what the answer should really be, you will likely stop at 6. It's better to first find everything to make sure this should be the answer, like not to be biased by what you see as the answer. So do you have questions about this simple program? And if there are no questions, then we will move to actually solving this problem. And let's first, for a moment, forget about the palindromes condition. Well, if you try to solve if you're solving a hard problem, it's better to do it part by part. So first solving something easy. Here we just counted distinct strings. It was the first step. Now let's count distinct strings that are subsequences of 2 given strings. So we're solving this problem, but we don't care about it being palindromic. then what is enough to do is to just introduce the second dimension to this dynamic programming. So we just create dynamic programming of n and m, so the lengths of the two strings, and we do the same thing. So we count strings such that if we do greedy algorithm for both strings in the and then dp of ij means the number of strings such that the greedy algorithm would get to position I in the first string and j in the second string, and the same algorithm will work. But here in the statement we were asked about palindromic subsequences, and it would be very hard to do it still from left to right, because you would have to remember what letters you used at the beginning. So then, like I said, that we don't have to distinguish between ABC, BC, AC, and so on. Right now we would have to remember it as state of our dynamic programming. And so here the straightforward approach, I think, would be to add 2 power 30 to the complexity, because we could just not really 2 to the power 30, like maybe that, yeah, maybe that, to maybe remember what we took from the right, from the left. Maybe it would be 2 power 60 actually, so 2 to the power length, but you only have to do it up to the middle point. But of course it's too slow, we must do something more clever. And often with palindroms we should do something either from the middle of a palindrome or from the 2 sides, because if there is, for example, palindrome ABCBA, we get the same first and last letter, and then if we remove them, the then second and second last letter is also the same, and so on. So this suggests that we should add 2 more dimensions, so let's say I2 and J2, and we don't now move just from left to right greedily. We move from the start and from the end. So, for example, if we decide that the first letter of that string should be A, then we find the first A from the left, also the first A from the right, and the same in the second string. If during a contest it's too complicated for you, you can also make the problem a bit simpler and remove the second string. Just count palindromic subsequence of one given string, and then 2-dimensional dynamic programming would be enough. And I will not waste time to implement this solution, but I can show my solution from a contest. Again, as I was saying earlier, it's hard to move around Topcoder website, so I just Google stuff, and I think that Topcoder match archive allows you to access codes. So that contest was wildcard round, I think. Not discuss. And I can just access my codes. And this is my solution from a contest. So I indeed created 4-dimensional dynamic programming. I initialized it with 0 n plus 1, 0 n plus 1. So I know that at the beginning our pointers, so those places from which we should move to the next letter, are 0 and n, and in the second string also 0 and m. And then we move to the middle with both strings. So I iterate over those states. I remember the number of possible ways, and inside I guess I should iterate over the next letter. So actually, instead of, just to make my program a bit faster, instead of iterating over a letter, I just iterated with one more pointer over place where that next letter should be. It's visible here. So Z is the index of that next letter to take in the first string, and if it's indeed the first occurrence of this letter, I try to find it also from the right, the same in the second string, and if I find all those occurrences, I increase the number of ways, the number of strings, and the answer is the sum of all the values in dynamic programming, just like with one string version. And that's it about this problem. It wasn't that hard, assuming you know the solution for one string and just counting distinct subsequences. Sorry. Do you have questions? And I will wait for questions a little bit, and if there are no, I will move to some different problem. Okay, I'm leaving a code for a moment, but actually I think the better thing is to give you a link, and I don't want to open my video again, so let me do a different thing. I will just it isn't the best solution, I think, but I will rewrite the address of chat from my laptop. It seems retarded, but should work. It didn't work. Open it, just pause it. Okay, I will do that. And I think I've removed my pop-up. Sorry. And I think I've removed my pop-up. Okay, I can close the video now, and I hope everything will be okay from here. You can open my implementation yourself in your computer if you want. Just follow that link, I pasted it in chat, and we will move to the next problem. And the next problem will be medium one from the same contest. It's, I think, not that complicated dynamic programming. This is a link to a problem if you want to open it yourself. And I will read the statement quickly again to remember what it was about, and I will tell you it like in shortened version in a moment. Also, in the meantime, if you have any questions not regarding problems we are solving right now, you can ask them, like general questions about contests or approach to problems. Okay, I will give you one more minute to read the problem, and in the meantime I will try to find my code. What's your stream schedule going to be? I'm just like, this is my second stream ever, and I'm not sure I will keep doing it. Like, it's just to see the possible format, just to know, to learn feedback from you. I also must see how demanding it is from me, how hard it is, and like, because it takes some time. It isn't that easy to code and explain at the same time. And if I decide to keep streaming, I guess it will be maybe 2 times a week. I will announce for sure on Codeforces how it will work out, and maybe sometimes some extra post-contest streams. But for sure post-contest streams are better when I'm a tester or setter, because then I'm sure I will be able to talk about solutions. For example, today in Topcoder round I solved correctly only the first problem. So of course it was stupid to talk about problems when I can't solve them, what of course happens. Would you solve problems for code, Jeff? Yes, I would. I just don't find competing in their contest right now very cool, because often the website doesn't work. But well, the same happened today with Topcoder. So the contest was postponed by 1 hour, sorry. But I think it doesn't happen often on Topcoder. If you enjoy doing it, then do it. Yeah, but of course it's also about the quality of these streams. So not also me enjoying it matters. Okay, I will tell what the new problem is about. It's called Gangsters, and it said, let's say that the number in the input is n. There are n people in a circle, and in some order, and every person will shoot to the next person and will kill him, or maybe eliminate him. I'm not sure it's about killing here, it's about shooting. Okay, and so they choose some order. So the first person will shoot his neighbor to the right, and then the next person in that some order will do the same. But of course, if someone was shot, then he doesn't shoot. So because of that, he saves some next person. And I have my code to the right, but we can, not this terminal. We can open some new file to do some explanations. And then again. Okay, so let's call them A, B, C, D, E, and let's say that they are in a circle. Then if the order, for example, is, I don't know, B, C, D, E, A, I will increase the font, because why not? So they are in some order, or maybe A. So on a circle we call them A, B, C, D, E, and let's say that they shoot in order B, C, D, A, E. So first B shoots to C, so C is dead. Then in our order we have C that is dead, so he doesn't shoot. Then D shoots to E, so we have something like this. Then in our order A shoots, so he kills B. And then E should shoot, but he is dead. So with this particular order, starting from A, B, C, D, E on a circle, two people would remain alive after the whole process. And the question is, how many people will stay alive? Actually, for given n, because this is the only number in the input, we are asked, considering all the n factorial possible orders, what is the sum? What is the sum of alive, or maybe dead, sorry, alive people in all the orders? quality is good. It's like the Josephus problem. Yeah, it's similar to Josephus problem in some way, but it's completely different. Josephus problem, if someone doesn't know, you can just Google that. It's a known puzzle where there are people in a circle and they count up to some number, let's say up to 4. They count in the order 1, 2, 3, 4, and whoever said 4 is, let's say, killed or eliminated from a circle. And then starting from the next person, they again count 1, 2, 3, 4, and this person that said 4 is eliminated. And the question is, given n, the number of people in a circle, and that number to whatever they count, find out who will, let's say, remain alive at the very end. So which person at the beginning, counting like numbering them A, B, C, D, E, which person will be the last one to stand. And that problem has some solution, and it's explained in Wikipedia. But here we have something different, and n in this problem is up to 150. The answer should be printed modulo 1,000,007,000, so modulo some prime, big prime. And one thing you should notice here is that you could do pre-processing on your own computer. If you have some slow program that, for example, runs 1 minute for maximum possible n, then maybe it's a good idea to run it on your computer to generate all the answers. It's then, of course, good to do it in several threads, so to do it parallelly. And here actually there is some solution that I think, for example, n to the power 5, that wouldn't pass, I think, this problem, or maybe n power 6, but you can run it with this complexity once in your computer, gather all the answers, and just copy paste them into your code. So then you just submit a table with 150 numbers. It isn't necessary here, because you can get n4 or maybe n power 3 complexity. And let's think about the possible approach for that. So when we find the sum over all possible orders, one important technique is to know that we also can count for every person how many times he would stay alive. Maybe this is a good approach for this problem, because if for example we know that there are 15 orders for which person A is alive, of course, because everything is symmetric, then there are 15 orders for which B stays alive after the process described here, and so on. Then we know that the answer is 75. The sum of the number of alive people in all the orders will be just the sum of those like 5 numbers. So 15 times n will be the answer. So it's equivalent to just count for one fixed person how many times, for how many orders, that person will stay alive to the end. And now, what other ideas you could get after reading a problem? Okay, we can analyze the process a bit. If we finish with some person alive, then a few persons dead, then again alive, and so on. For example, is it possible that 2 adjacent persons are alive? It isn't, because at some moment A had to shoot to B. So for sure A and B can be both alive. So we must have A, some number of alive persons, then some other person, and so on. Now I can move it a bit to the left, because maybe my face will cover the code. And okay, what else we can do? These intervals are almost independent from each other. If we know what is the situation at the end, then we know some conditions. So here at the beginning, here it was D, but he was apparently killed, and we know that D didn't kill the next person. So apparently C killed D before D shot to E. But since C had to kill D, apparently he wasn't killed before that. We know that at some moment the second person killed the next one, and it had to be later. Also A killed B. So what we actually noticed is that in an interval like this, so where there is a person alive, some number of dead people, and then again a person alive, they had to shoot in some particular order. First D, so the last of, in this interval, the last person shot first. Sorry, it's impossible because E isn't killed. Sometimes later D shot. My mistake was that E isn't killed. So apparently C killed D, then B killed C, and so on. If they stand in a row, like some part of circle, they had to kill each other, first the last person, then the second last, and so on. Question is, does Scout Jam has a time limit as well? Yes, all the contests has some time limits. And also Topcoder, if this is your question. And I think Topcoder website doesn't show us time limits, so they aren't printed in this site, but they are 2 seconds by default. Okay, so if we have an interval with 3 persons killed, then we know exactly that the order of them shooting was CBA, and also we know that D, so this person, had tried to shoot after the previous person killed him. So how many options are there for this situation? Well, if we only consider the order between A, B, C, D, so A, B, C, D, A, B, D, C, A, C, B, D, and so on, then how many orders are there such that this situation happened? And the question is, I think, 3 or maybe 4. We only know that the first event was C shoots, then B and A must be in this order, and D at some place. So possibilities are CBA D, and also D could be before that. So these are 3 possibilities, and generally the number of ways for that, the number of possibilities, is equal to the length of an interval, the number of killed people. How many hours did you spend training in order to be here? It's very hard to say, to count. I think I started programming like 6 years ago, or around that, and on average I would say I spent, I don't know, maybe 15 hours a week. It's very hard to estimate because where, for example, we were preparing for ACM ICPC, the number could be much bigger than that, and because just our trainings, I don't know, 2 or 3 5 hours trainings plus absolving takes a lot of time, and on some camps you spend like 10 hours a day, so then it will be 60, 70, but I would say 15 hours a week on average for a few years. Okay, back to a problem. Here, so if we have interval with 3 dead people, we have 3 ways for that, if we only care about the order between them. The thing is, of course, that we should consider order of everything, so it will be a bit harder. So now let me think for a minute how to deal with that. If I remember correctly, during an actual contest it took me less time actually to solve this problem. But maybe I will get a solution again in a minute. I just don't remember it. I think the idea should be to somehow combine for example, 2 adjacent intervals. So if we have, let's say, this interval, and we just know that the last person had to shoot before the previous one, and we want to combine it somehow with the next interval, so with this one. So we could iterate over the size of this interval, the size of the next interval, and maybe do something like dp of size, the sum of sizes is dp of 1 times dp of b times maybe some binomial coefficient, because we combine the orders. But I think it would lead to worse complexity, because for sure we would have to iterate over size of one interval, size of the other interval, and so maybe it would be fast. Can you recommend a book for C++ for competitive programming? I think if you are a beginner, you should read Handbook Programming Code Forces. Google something like this, and you will find a PDF book by a guy from Finland who did some explanations from zero, like this is DFS, this is how you should print, this is what you should do. And if you're more experienced, then just solve problems. Okay, so this is some idea. Let's think if it's possible to turn it into actual solution. Of course, here we don't anymore remember about the fact that what we noticed here. So we should only, it's enough to count orders where A stays alive. So our statement, our problem became maybe a bit easier, because now we just want to, we don't anymore care about the total number of alive people. So of course, without that observation, here we would have one more dimension to this dynamic programming, what would increase the complexity maybe a lot, because we would also have to iterate over the number of alive people so far, or maybe in this interval, something like that. So here we don't need that. And actually, just to for sure go to a solution with good complexity, I will take a look at my code and I will explain what it does. So what we did so far is what I would go through during a contest, trying to solve a problem, so having some various ideas, and maybe it's a good idea here to move code to the left to make sure you see it. And what we do, I have 3 dimensions programming, and it's I have some comments, so maybe we'll be able to understand that. So I have dp with index of some person. K means, I will explain in a moment, and the number of dead people. So here I apparently have the number of dead people as a dimension. And if I understand correctly, what I came up during a contest is completely different from my ideas now. So the thing is that right now I didn't remember my approach from a contest, and it just shows that there are many possible approaches. And during a contest I noticed that I can go from, let's say that everything is on a line for a moment, just to make things simpler. I can go from left, so everything so far we can forget. I can go from left, and let's see in this prefix of people what is important so far. So let's iterate over prefix that is already considered. Now K means at which moment the last person shoots, and we also store the number of dead people. So what happens here? If you already chose the order of shooting for some prefix, so you know which of them shoots first among them, which shoots second, and so on. So for prefix of size A, there are A factorial possibilities for that. We don't care so far about the things to the right. And if you chose that order, the only thing that matters, the only 2 things are the number of dead people, so the number of people that were killed to the left, and also this last person in the prefix when he shoots. So for example, if we had 5 people to the left, we don't have to remember whether whether for example B is killed or C is killed. We only have to know whether E will have a chance to shoot the next person, and what is the number of dead people so far. So we say that, so instead of prefix in my code I have a variable who, what meant what person I consider now, and I guess that K should be between 1 and who. So right now it would be among these 5 people, when did E shoot to the next person? Because this will tell us whether he managed to kill the next person, or whether that next person managed to shoot first somebody more to the right. And I will repeat that so far we only consider a thing on a line, just to make things simple. It's often what we should do if a problem is too hard. And of course that is the number of dead people that is needed, of course, for the final answer. And let's see what dynamic programming should do. We iterate here with 3 for loops over prefix, so which person we consider now, which here is which in order that person is, so from the right it was the number K, and the number of dead people, that is also up to who. And apparently I marked maybe I marked the first person as that already, because I iterate from 1 instead of from 0. And not to use some long variable name later at the bottom, I create some helping variable me, and I take value of dp, the number of ways, and I iterate over what will happen here. So k2 in my code means that next person to consider what is his position in the order so far between 1 and who plus 1, because now we consider person number who plus 1. So for example here we would move to person f, and he will either shoot first among these 6 people, or second, or up to 6. So this is number k2. And now this is some special if, what doesn't matter for a moment. I will explain it later. It's like some flag. And if that new number k2 is bigger than which, so if f shoots before e, so let's just copy maybe these ifs and decrease font a little bit. So this line means k2 is later, so e shoots before f. So if that's the case, then f will not manage to shoot to the right. So here we don't increase that by 1. And in the case later, you will see that that is increased by 1 in dynamic programming. So indeed, otherwise, if f shoots before, then he managed to kill the next person, so apparently G, and only then E will shoot him. So this is some logic that makes sense already, except for one thing. It's also possible that for this prefix we know that E will not shoot anybody, because he was killed himself before he managed to shoot. So as is said in my comment in my code, that which variable, so k variable equal to 0, is a flag that means E, next person, E, will not shoot at all, for sure. And then this line means that for sure the next person F will be alive, because he will not be shot, and we must decrease the number of dead people by 1. And this should be enough to solve a problem for a line, but we are on a circle. And a good trick to change this circle to a line, to now make everything work, is to just say that without loss of generality, we can say that in our circle, so let's say that there are 6 people, A, B, C, D, E, F, we can say that F shoots first. Of course, it's possible that somebody else shoots first, but it's a symmetrical situation. And if F shoots first, then for sure A will be dead, and F already shot, and he will not shoot anymore. But now A can't kill B, and we have a problem on a line with 5 people. And also we know that F doesn't shoot anymore, so the last person will not shoot. So actually we care only about these 4 people, and this is why in my code you can see that I iterate over person up to n-2, because I only solve a problem on a line for n-2 people. And after I do the main logic, so the main dynamic programming, then I must sum up the answer. And what I do here, I iterate over all possible final states, so states with n-2 people already considered, and to the answer I think I must add what do I add? Apparently I don't add the number of ways multiplied by the number of dead people. I must understand it, because the problem asked us for the sum over the number of alive people. So here my guess would be that I have to increase answer by the number of ways multiplied by the number of alive people. Okay, so actually the input, I didn't tell you the statement correctly. The input didn't ask for the sum over all the possibilities. Instead, where is the statement? The statement is here. So actually the statement gave us one more variable, alive, and we are asked about the number of orderings for which there is exactly this number of alive people. And then, of course, it makes sense to make if apparently, so if there are a dead people, then for sure there is n minus a alive people, and if it's exactly what was given in the input, we increase the answer by the number of orders. And that's the solution. The complexity is, the memory complexity is n cubic, because we have 3 dimensions, and the time complexity is n power 4, because we iterate over states, and here we have 1 extra for loop inside. So there are 4 nested loops. And with these constraints like 150, it should work very fast in like maybe 100 milliseconds. You can also notice one strange thing that is, well, a trick to make your code faster. Instead of integers, I use, so I have typedef long ll, and I use longs for my dynamic programming. And in the main logic, when I increase the number of ways at some cell by that variable that is created for convenience, I don't do modulo. Why? Because modulo is very slow in C++ and in other languages as well. So to make it faster, in that heaviest place in my solution, I didn't do modulo. I only added something what was faster. And when I get to a cell, so now I consider this cell and I want to increase the number of ways for some different cells of dynamic programming. Right now I do modulo. So thanks to this, I have only n cubic modulos instead of n power 4. And the code will be like 10 times faster. Of course, you must be careful with things like this, not to overflow something, because if you many times increase something by big numbers, you can not fit in long log. So why does it work here? It works because since I modulo at this moment me, and the variable me must be smaller than 1 billion, well, 1,000,000,007. So here, to some cell, I can add 1 billion. And since my program has some fixed complexity, like n power 4, for every cell, I will add at most n power 4, and actually much fewer than that, something of order billion. So from this we know that the value at every cell will be at most billion times my complexity, the number of times I added to some place. So thanks to this, long is enough for sure, and I indeed don't have to do modulos everywhere. And so the complexity is n power 4 with only n power 3 modules. Do you have questions? and I will try to find the next problem, I think the last one for today. It's a pity that Topcoder round was moved by 1 hour, because of course I planned things a bit differently. I didn't know that modulo was that slow, thanks. Yeah, like some operations, for example in C++, are slower than others, and for sure you should know that division and modulo, because they are basically the same thing, are very slow. You can assume that all other operations like adding, even multiplying, are very fast. Actually multiplying is a bit slower, but still quite fast. And maybe the fastest operations are bit operations like XOR, but it doesn't matter much. So I just remember that modulo and division is slow. Usually it doesn't matter if you have good complexity. Well, maybe if you have to squeeze into time limit a little bit more, but it will for sure matter if you have extra logarithm in complexity. Then in that heaviest place of your program you must try to avoid modulo. Some other trick I can tell you, I think it could also be used in this problem, is, for example, let's say that where you can't use trick like this. You can't use it, for example, if you do something like dp of ab, or maybe just of a, plus equal dp of b times some value. So this is an often case with dynamic programming, that you don't, like previously, add something of order modulo. So something of order 1 billion. Here you insert something that could be 10 to the power 18. So you can't allow yourself to add many times to one module. And instead of, for example, some program could be like this. Let's say that we have array of size n, and some program that would work quite slow would be the following one. Times, I don't know, some value of b. Let's say that values of b are given in the input. So of course you can't do this even with dp of a taken with modulo, even if you have longs, because here you add something of magnitude 10 to the power 18 and you can't add that use that many times, because you will overflow longer. What is correct to do, of course, is to do dp of b is dp of b plus dp of a times that value modulo prime number. And so this would be the same, this would be the same logic, but it's very slow. To make it like 10 times faster, a good hack that I often use is to do this one. So we add, and now only if dp of b is bigger than something, then dp of b taken module. So what is that something? Let's say that it's so longs, I think, store numbers up to 9 times long stores numbers up to 9 power 9 times 10 power 18. So here we can say that if dp of b is bigger than 8 times that, so 8 times 10 power 18. Then we do modulo. And also we then need modulo here just to make dp of a to be smaller than 1 billion. And here I assume, of course, that modulo is something like that. And actually this code will do like at least 8 times fewer modulos, and thanks to this will be 8 times faster. If you want to make it even faster, instead of long use unsigned long, and then here you can use even bigger value, something like 17 or maybe 16. Of course, it's stupid, it shouldn't be used in intended solution, but often it will make your code much faster, and maybe it will get you accepted. People use it all the time. And if okay, we can also here write something like unsigned long max or something like this. There is a variable like this in C++ minus modulo times modulo, assuming that modulo is of time long. So this would be like more automatic thing, just not to write some constant in your code that you could mess up. How do you visualize 3 or higher dimensions array? Well, I don't visualize that unless it has some good representation. For example, if the statement says something about like cubics, like something about 3 dimensions, then for sure maybe the solution will use array with 3 dimensions, and you will just have to think about those 3 dimensions. But for example, in this problem where I had 3 dimensions, you don't visualize that. You just think in this dynamic programming what values are necessary to remember to be able to move further. So here the only thing I visualized is that there is a sequence of people, and we considered everything up to some moment. So only this part is what I would visualize while thinking about those people in line. We considered some prefix. Here the other 2 dimensions only tell us some information about the beginning, information that is needed to restore the answer. So this is why we have that number of dead people, and K2 was needed just to move to the right to know whether the next person will be killed. So you don't have to visualize everything. Okay, and let's try to find some last problem to solve. Maybe it will be alchemy. I think it's a good, not usual problem. Or so either it will be alchemy, or I can find something that is dynamic programming as a problem before, just to keep it one topic. So just tell me if you prefer dynamic programming on some unusual problem. Okay, So let's try to find some dynamic programming. And let's not make it very hard. Actually, I think that a problem from Polish round was quite nice for that. Some cards, because it uses a lot of techniques that are useful. So it's good to solve problems that don't have very unusual and particular solution, but instead use techniques that you could use in other problems. So let's spend like a minute to read the problem. Also, again, later I will try to say it with my own words. Somebody says tomorrow you will solve algo problems in HackerRank. For sure tomorrow I will have a break from streaming. I streamed today and yesterday and I'm not used to that and I don't have enough time, but we'll see in a few days. Okay, let me say the statement. We are given n cards, each with number written on one side and some number written on the other side, and we want to, for every card, we want to choose a side that is up, so we choose one of two numbers. Then we have some sequence of n numbers. We somehow sort them to get the biggest or smallest. Smallest. So if we already chose a number from each card, now we kind of sort them to get the smallest possible total number, total meaning concatenation. So for example, if we have number 15 and we have 8, then we have 158. And then we get some new very long number, and the task is to consider all the possible 2 power n ways to choose numbers from cards, and for each possibility to shuffle, to order cards to get the smallest possible concatenation number, and to find the sum of those big concatenation numbers modulo billion plus 7, a prime. And of course, since n could be big, could be up to 100, and numbers are up to 1 billion, the concatenation will not fit in integer type or in long type, but it will not be a big issue. Like this video, thank you. So what we should do? First, again, so it's always the case for hard problems, we should try to solve an easier version of this problem. Let's say that we are only given one number on every card, and we want to know what is the ordering that will produce the smallest concatenation number. Of course, the first guess could be that we should sort numbers increasingly. So for example, if we have numbers 5 and 80, then we put 5 before 80 and we get 580. And it should be better to write that if we have 5 and 80, then indeed putting it this way will produce 580, and putting it the other way will produce a bigger number, 805. So I guess could be that we should sort numbers. But it isn't necessarily true. And in our first example with numbers 8 and 15, sorting them from left to right gave 800 something, and putting 15 first, even though it's a bigger number, will produce 158, a number with the same length, the same number of digits, but smaller. So maybe we should sort them not necessarily increasingly, but by the first digit, so maybe lexicographically, because if you want to get small total concatenation, then the length of the concatenation is fixed because it's the sum of lengths of numbers, and you just want to get the minimum possible first digit, and being fixed that, you want to minimize the next digit, and so on. So what makes sense and is kind of intuitive is to just sort the numbers as strings, to sort them lexicographically. Then 15 would be before 8. So this is one possible approach for that, and the other is just to say that, okay, if we have two numbers, for example 15 and 8, in our code we can concatenate the two strings, and also we can concatenate them in the other way, and thanks to this we can say what is the better ordering, which one produces a smaller number. We can just write a function bool better that takes two strings, and for example let's say that it's a comparator between two strings, and if a plus b is smaller than b plus a, and operator smaller than for strings compares it lexicographically, then we return true. What would mean string a should be first, otherwise return false. And actually we could use this comparator to sort the strings. It isn't that obvious that you could indeed use that, because maybe for two strings we know that this should be before the next one, but given more strings maybe some smarter order is better. Especially it's hard to decide if one string is prefix of the other, but it's possible to prove that this is valid. Unfortunately, proof isn't easy. So after stream you can find editorial for this problem and read a proof there, but proving it isn't easy. During a contest you should just, I guess, assume that, because you would only waste time proving. If I wanted to prove it here, so given more strings, some strings a, b, c, d, we want to know if they are maybe sorted in a good way. So what we could do is to think whether some two strings should be swapped, some two maybe adjacent strings. So to check if it's good to swap b and c, we can check it with this comparator. And of course the trick is that maybe it's good to swap a and c. And if they're if no string is prefix of another, so for every two strings they are different at some digit, some first digit, then it's easy to prove that we shouldn't swap, for example c and a here, because we minimize the first letter, that would be the first digit that would be different. So then we could say that if A is lexicographically smaller than B and B is lexicographically smaller than C, then also it must be true that A is smaller than C. It's harder to prove for complicated comparator like this. So for comparator, that would also work if one string could be a prefix of another. So this proof we will skip. It's a total order. Maybe we can define sort function by comparing the answer for two concatenations. Yeah, I guess I've read this comment too late. I've already talked about it. So yeah, the solution, the good approach is to use this comparator, so sorting just two strings for all the sequence, all the input, but it's harder to prove that it's correct. But maybe your approach should be, otherwise we couldn't solve this problem. And we for sure have to be able to sort, because in particular the input could contain all the time AI equal to BI, and in that case exactly you would have this problem, to given a set of strings, to sort them, to minimize the concatenation, and we would just print the value of this concatenation times 2 power n, because this is the number of possible ways to flip cards as in the statement. Okay, but here we are given pairs of numbers, and let's try to deal with that. And here we will do something similar to what we did not use in the problem about the gangsters, because in gangsters I said that we could, instead of counting what is said in the statement, we could count for every gangster in how many orders he will be counted, so he will stay alive. And here, for every number, for every AI and for every BI in the input, we could count how many times it will be used. So how many times it will add something to the answer, to the total answer. So actually, number, let's say A0, so the first number on the first card appears in exactly 2 power n minus 1 ways to choose numbers, because if it's at the top, if it's chosen in the first card, we have 2 power n minus 1 ways to choose numbers from different cards. But of course it's also important where it is in the concatenation, and here we will use a nice observation that is useful in many problems, that it's still possible to count how much it adds towards the answer. So I would call this technique maybe find the sum, how much some number A adds towards the answer, adds or maybe contributes. We'll finish watching the recording tomorrow. It's 2 AM here. Okay, bye guys, and yeah, sure, watch the video later. And in this problem it's possible to use this technique to find out how much something adds towards the answer, because if we are given, let's say, 3 numbers and we know in what order we should put them in the concatenation. For example, let's say that the numbers are 1, 2, 3, 500 and 8000. Then, and indeed they should be put in this order. After concatenation we have 1, 2, 3, 500 and 8000. And we know how much here 500 adds towards the answer. It adds 500 times 10 power 4 or maybe 5, because here it's important where that 500 is in the total concatenation. So if there are 4 digits to the right, So apparently 500 is multiplied by 10 power 4. So we can write that this concatenation is equal to 123 times 10 power, I think, 7 plus 500 times 10 power 4 plus 8000 times nothing. So times 10 power 0. So for every number we want to know what is the number of digits to the right from this number. Then we know that we should add this number times 10 power the number of digits to the answer, because we actually find the sum of values like this. In Barcelona bootcamp, sharing the time zone. Yeah, it's a bit strange to stream for so many different various time zones. Okay. And if we notice something like this, we can do dynamic programming. How? Let's focus on A0. So the first number in the input. We want to know how much it adds towards the answer, and we will do the same thing for all the numbers in the input. So we say A0 is chosen from the first card. For all the possibilities of choosing numbers from next cards, we want to know in how many after then sorting optimally the numbers, that number A0 from the first card will be, let's say, rightmost number. Let's say that there are X ways to choose numbers on the right so that A0 would be rightmost. Then we would just add X, the number of ways, times A0 to the answer. And if there are X ways such that the number A0 will be almost rightmost, but there will be one digit more to the right, then we add that times 10 to the answer. And if we know what strings, what numbers should be put to the right, then we actually know in the input which numbers would increase that number of digits to the right, and we can do dynamic programming. So we will likely need dynamic programming, where dimension is number of digits to the right. And let's just say that it's dp of right. And here, once again, I can find my code, not to waste time implementing it from zero. Topcoder match archive. It should be Poland round. Actually, I think not this. I think I didn't implement it, so we'll take a look at someone else's code. Let's say that maybe Petr, even though he writes in Java, but it should be the same solution. Maybe it will be a bit hard to understand, but let's try to find something shorter. Okay, this seems to be maybe a shorter solution. So this is commented. Okay, what we do here? We iterate over a number that we want to add towards the answer. So first we have some A0 and so on. We want to consider all 2n numbers. Then we iterate here over every another card, so everyone except this one, and we iterate over which number we consider, and that function splash apparently sorts two numbers, so it's our comparator here from the right. So if he checks apparently if this number should be to the right, and if yes, then taking it means that we must shift our number A0 or some other number we consider to the left by the number of digits. So to some total contribution towards the answer, we add 10 power something. We also have plus equal to 1. What it does? Okay, so mul is some total multiplication, and for every number we want to take that 10 power something. So for example, we for some number see that it takes 3 digits, it has 3 digits, and it would be to the right, so it would multiply the contribution towards the answer by 1000, so 10 power 3. If some other number has 5 digits, we multiply by 5, and so on. So if we are set which numbers are to the right, then we just multiply it. And here we need some dynamic programming, what actually, as you can see here, can be done without an array. Because if you consider some number of cards already, then for all the 2 power k, where k is the number of cards, possibilities, if you sum up those 10 power something things, you don't have to actually have dynamic programming with the number of digits to the right. It's enough to just store the sum of those powers of 10. So instead of having, for example, dp of 0, dp of 1, dp of 2, and so on, here that mul value just stores dp of 0 plus dp of 1 times 10 plus dp of 2 times 100, and so on. And then it's enough to just, if you see a new number that has 3 digits and would be to the right, then you just consider multiplying it by 1000 and add it towards the answer. And a nice trick here, like the nice implementation technique, is that, I think it's used here, is that you don't have to use int or long if you do modulo, at least in C++. I think we should find here a class for modder. Yeah, it's here. So you can create your own struct that has int, and you can override all the operations with adding, multiplying, and so on. And then here in your code, you will never forget about modulo. And a disadvantage of that is that it's harder to do tricks, like I showed in the previous problem, where we avoided computing modulo so many times. And the complexity of the code is n, the first loop, times n, the second loop. We iterate over cards, so n squared already. And here we need to compare two numbers. So if we do this comparison in constant time, the total complexity will be just n squared. And if we do it in O of length of those numbers, so it's 30 in the input, then it will be n squared times that 30. And it's the simplest possible solution. So except the comparator, it's just like 15 lines. What is often a case for dynamic programming. And it was the last problem for today. Maybe we would solve a bit more, but the SRM was moved by 1 hour and it's already late for me. Thank you everybody for watching, and I think on Codeforces I will post info about the next stream, but likely it will not happen in the next day or two. So see you, bye bye.